Hello students, this is Professor Praveen Patil. Uh, we are focusing on unit number 6. Topic is Future of Cloud Computing Part 1. If you look up on our syllabus for unit number 6, that is Future of Cloud Computing, here the syllabus is divided into 3 parts. The first one, how the cloud will change operating system, location aware applications, intelligent fabrics, paints, and more. The future of cloud TV, the future of cloud-based smart devices, faster time to market for software applications, home-based cloud computing. The second part, types of cloud. The first part, the second part is mobile cloud, autonomic cloud engine, multimedia cloud, energy-aware cloud computing, jungle computing. Third part, Docker at a glance, process simplification, broad support and adoption, architecture, getting the most from Docker, the Docker workflow. I will be creating a video on the first part, the first the first part on two topics. The other videos or other videos will be uploaded on Google Classroom. The first part, if you look at the first part, is the first part is dependent upon application and futuristic applications of cloud computing. The second part is dependent upon types of cloud, which will help us to deploy or develop applications. The third part, that is Docker at glance. First of all, Docker is a tool designed to make it easier to create, deploy, and run applications by using containers. Containers allow a developer to package up an application with all of the parts it needs, such as libraries and other dependencies, and deploy it as one package. Part 1, the future of cloud. Here we will be focusing on how the cloud will change operating system, location aware appliance applications, intelligent fabrics, paints and more, the future of cloud TV, future of cloud-based smart devices, cloud and mobile, how HTML5 will drive mobile applications, faster time to market for software applications. Coming on, how the cloud will change operating system. So there are different flavors of operating system. You all know about operating system. Nothing to explain about operating system, applications or what operating system do. So in cloud here I will focusing on operating system. There are different flavors of operating system from real-time OS, desktop OS, all the way to mainframe OS. The most recent OS is cloud OS. So we are focusing on cloud OS. In general, the kernel which manages memory, processes, etc. Device driver which drive different hardware from different vendors. User interfaces including command line shell and Windows system. File system which provides a hierarchical way to persist data. Security which authenticates users and protects information. Depending on type of OS, for example, an embedded OS may not have a user interface and everything is controlled remotely. For desktop OS, you may have extra commonly used applications such as calculator, calendar, browser. With virtualization, operating systems moved up in software stack. So it is being moved to software stack. That means it is being embedded in an or it comes in a software stack. The role of managing and abstracting hardware is relinquished to hypervisors. Now hypervisor is maintaining everything. That means underneath the virtual machines. So the OS is squeezed by virtualization from the bottom. Okay, the working of OS or the OS is now the working of OS is now or the OS is being looked after by virtualization now. It's called as in the main thing or the main hero of the virtualization is hypervisor. What is a hypervisor? Already I have explained in previous classes. So before virtualization, there have been concepts of software middleware, including database, messaging, etc. These provide a higher level platform for application and result in higher quality of product and higher developer productivity. Also, the rise of software virtual machines like JVM.NET have abstracted the OS services to higher level of programming API, that is an application program interface. So the OS is less important from application development point of view. It has been squeezed, that is, it is being squeezed, or the role of the OS is being getting lower because of the hypervisor coming in picture from top level as well. Why an OS still important in cloud computing? Why OS is required? Though we are having a hypervisor is managing everything. Why? Typically, OS is needed by, or very important aspect of OS is IP address. So an IP address has two functionalities in networking, helping routing traffic in and out and identifying a particular operating system. Hypervisors such as ECX do own IP address. They are having an own IP address, but for management purpose, not for computing workloads. So ECX, the hypervisor, it manages everything, but it doesn't handle computing workloads. Middleware and applications do not own IP address, but rather bind themselves with a particular service port as needed. The second part for IP being an ID is critical. It's like public interface. Unless we can move up the IP up to the middleware or application, the OS continues to be a critical component. Now talking about something about IPv4 and IPv6. With IPv4, it is not practical to assign an IP to an application due to limited number of IPv4 addresses available. With IPv6, it's possible because there are plenty of IP addresses. But that means plenty of IP addresses, that is plenty of IP addresses available. But then the question becomes whether the range is really needed, whether change is really needed. For one thing, moving an IP attribute up to the middleware or application will totally change people's perception, which may hurt adoption. Firstly, depending on type of cloud, you may not need to know about OS, but it's still critical for operations. Instead of innovating new features, the imperative work there is to make the OS reliable, convenient, and secure at the time and same time keep up with the new CPU architecture. Now, why OS is important in cloud computing? Second part. Secondly, there is an OS for end users. One could build similar desktop user app experiences with browser like Google Chrome OS, but it's still a desktop with feature which is already even everyone is similar with. These OSs can live in cloud and serve end users remotely. For better mobility and easy management of personal data across various desktop, netbooks, smartphones, set-top boxes, there is need for better way to synchronize them. Operating system exists to allow users to run program and store and retrieve data from one user session to next one. It is called as cloud. Virtualization, most server operating systems now support and will continue to support hypervisors that allow multiple operating systems to run simultaneously. Virtualized servers will continue to play a large role in driving the behind-the-scenes operations of the cloud. Many organizations are going to an operating system on-demand model for which servers download and uses operating system application and environment settings to any computer the user logs into. With the advent of more programs that run within browser, there may be much less need for powerful desktop operating systems such as Windows and Mac OS. Location-aware applications. A location-aware applications utilizes data from GPS, that is Global Positioning System, capabilities built into mobile devices to integrate an individual location into processing its performance. The GPS capabilities are built into more devices application. Will begin to deliver more location-aware solutions. For example, a stroll through a mall, that means when we are roaming in a mall, may result in coupons being pushed to your handheld device. That is called as working of location-aware application. Grocery store passaways may become interactive zones with retailers able to deliver bid-based coupons in real time to influence your purchases. Real-world QPS mobile coupons. Users of computers and handheld devices are becoming on-demand consumers. They want what they want, when and where they want it. QPS mobile coupons provides insights into future of coupon clipping. The site currently delivers on-demand location-aware coupons to states along the east coast of US. Now, coming to intelligent fabrics, paints and more. The ability to connect devices to cloud from any place at any time will open the door to wide range of cutting-edge applications. So, intelligent fabrics, paints and more are the applications of cloud computing. At the obvious end, devices that once had to be read by utility or city employees, such as electric meters and parking meters, will connect to the web and create a report. At cutting edge, intelligence will be built into fabrics of our clothes, bedding, and furniture. These intelligent fabrics will provide a wide range of services, including the following: automatically adjust room temperature when body temperature becomes too warm or too cold, notify rooms when we enter or leave, or so that lights, music, and other devices are automatically controlled, monitor body functions such as blood pressure, blood sugar level, stress, and more, and notify the person and adjust the environment to affect those functions, notify others when an elderly person has fallen, provide deterrence against mosquitoes and other insects. So these are the applications of intelligent fabrics, paints, and more. Coming to the second part, Wearlum is a smart t-shirt designed to minimize the risk and cost of low back disorders. So this t-shirt will diagnose lower back disorders. It uses a network of motion sensors to measure a person's posture at work, sending this information via Bluetooth for automated real-time analysis on tablet. Until companies have had to send employees to film people at work and then analyze the video according to OWAS methodology, that is OWACO Working Posture Analysis System. The Wearlum t-shirt, which is available in version for men and women, removes the need for invasive and costly video-based processes which take a person away from the workplace. How the Wearlum t-shirt looks like, the figure is in front of you. With the data provided by t-shirt, 3 flexing sensors, 6 elongation sensors, 9 temperature sensors, and 5 accelerometers, company can provide accurate insight into workers' position and suggest way for improvement. As well as improving the quality of result, we estimate that Wearlum reduces the time needed for procedure by 50% and cuts the cost of intervention by 40%. So in exams, if the question comes on intelligent fabrics, paints, and more, you can give this example of Wearlum t-shirts. What fabric, intelligent paints, and more. The more on this, the more topics. Intelligent paint becomes increasing popularity. The demand for new technology in field of paint has increased significantly in recent times. Sophisticated solutions such as washable and stain-resistant paints are already commonly found on the market, but manufacturers have also begun to offer more advanced products that offer additional and unexpected benefits. Examples of these are antimicrobial paint, photocatalytic paints. Okay? The antimicrobial paint, the type of paint was created to prevent the proliferation of fungi and bacteria, particularly in rooms with high moisture levels. Photocatalytic paints. This paint is resistant to washing and airborne pollutants. Similarly, new paints being developed change form based on environmental conditions. Currently, paints can change color on roads to indicate the presence of ice. In the future, intelligent paint may report driving conditions back to color. Intelligent paints turns road pink in icy conditions. So more about this, you can read on the following link. When temperature drop down, so icy conditions, how does paint helps us to prevent accidents? For example, say in icy conditions, if a paint is being given, the smart paint is given, that is paint is white. As soon as the temperature drops, it can trick you to judge road conditions accurately. Soon, however, some roads could give drivers clear icy warnings by turning themselves pink. A new temperature-sensitive varnish developed by researchers at French company Eurovia can be applied to road surfaces to warn drivers about dangerous conditions. The technique still at testing stage might help prevent ice-related traffic accidents in future, the researchers say. Researchers at Eurovia tested the varnish on road at different sites in France. They painted squares around the meter across into roads and observed how the normally transparent varnish turned dark pink when temperatures dropped below 1 degree Celsius. When the temperature rose back about 2 degrees, the coating became colorless again. So this is a good example of intelligent fabric paints. Thank you for this session.